For the function f of x equals negative x squared plus 4x minus 3, find the intervals where the function is increasing or decreasing. All right, so what you need to do is you need to find your critical points. You do that by taking the derivative, setting it equal to 0, and solving for x. Critical points gives you a local maximum or a minimum, right? If you have the derivative, if the derivative is positive, your function is increasing. If the derivative is negative, it's decreasing. So what we need to do is find the critical points and make a sign graph based off of that information. So the derivative of f of x is going to be using the power rule. So the derivative of negative x squared is negative 2x. The derivative of 4x is plus 4. The derivative of negative 3 is nothing. Set it equal to 0, and solve for x, right? Subtract 4, negative 4 equals negative 2x, divide by negative 2, divide by negative 2, and x equals positive 2. So whatever this graph looks like, I know it changes its direction from negative to positive or positive to negative, whatever, at 2. So this is my f prime, okay? This is my derivative sign graph. What I need to do is I need to pick values and plug it into the derivative to see if I get a positive or a negative slope. So I'll pick easy numbers like 0 and 10 and plug them in and see what happens. So f prime of 0 is going to be negative 2 times 0 plus 4. 0 plus 4 is 4, which is a positive number. Now let's do the same thing with 10. Negative 2 times 10 plus 4 is going to equal negative 20 plus 4, which is negative 16, a negative number. So based off of this information, since the slope is positive all the way up until 2, we can say that my function is increasing on the interval negative infinity to positive 2. Since my derivative is negative from 2 on out, we could say that my function is decreasing on the interval 2 to positive infinity. And we kind of know that because that's a parabola that's going downward. So, if we kind of just do the whole vertex form thing, found out that x is going to equal 2 here, this all makes perfect sense. But you know what? We used calculus instead, and that's just so much better.